All right, so the first thing we do is we solve each equation for y. So we can see this first one is in standard form. What letter do we always need to get by itself? Y, right? To get it in slope-intercept form. And so the invisible coefficient that goes next to x is what number? 1. So put that invisible 1 there. Make sure you guys are writing this down so we got this down. So first thing, I'm going to put my invisible 1. And I can see Fernando is already moving x to the other side by subtracting. So the next thing we do is we got to move the x to the other side because we want to get y by itself. Now, can I combine these? 1 minus 1? No, they don't have the same last name. So what we do is we rewrite it. Y equals negative 1x. And since that's positive, it would be plus 1. So the next thing that I'm going to do is I'm going to graph this line just like we did on the do now. So what is the y-intercept here? 1, right? So I plot at 1. The biggest mistake I see with graphing is that you guys plot on the x-axis. Make sure you're always starting at the y-axis. Then, if it's negative, am I going down or up?
Down.
Down. So it's down 1 over 1. It's always to the right. Rise, run, right. And I'm going to continue it so it looks like this. And then draw a line through it. So the first one I did in black right here. The second one I'm going to do in red. So my second equation is 2x minus y equals 5. So who can raise their hand and tell me the first thing I would do to get y by itself? Subtract 2x, right? Can I combine 5 minus 2x? No, they don't have the same last name. And so you end up getting, don't drop that negative, negative y equals negative 2x plus 5. Now, what's the invisible coefficient that's next to that line? 1, because now there's a negative. So I'm going to have to divide to get y by itself. So I need to divide each term by negative 1. That just changes the signs. So I end up getting y equals 2x minus 5. So that's just going from standard to slope-intercept form. Then I'm going to graph it. So, Charlie, how do I graph this? Beautiful. Start at negative 5. Start at negative 5 up to over 1. And I'm going to keep going because I see it doesn't hit that line yet. Up to over 1. Up. I see it hit that line. And that's the point of intersection right there, where they both, see where they both hit 1 point? That point is known as your solution. So this point right here, maybe use a different color. We know that this point is our solution. When they ask for a solution, it means where they. And so who can give me the coordinates of that solution? Go for it. Beautiful. So my x is 2 and my y is negative 1. So your solution is always going to be a point. So it's the point where both the lines have the same coordinate. Right there, you can see they both meet at that point 2, negative 1. Does that make sense?
Yes, ma'am.
Cool. So we're going to just look at a couple different ways we can see this. So does everyone have this down? All right. So sometimes it will look like a table. So when we're solving for system equations, so I'm back at the front of that packet from today, we're searching for a solution. The solution is where the two equations meet. And so here are two tables, right? There are two tables that have points. So when we're looking for a solution, we know it's when they have the same point in their table. Who can raise their hand and tell me where do you see the same point or the same x and y in this table and that table? What coordinate would be the solution right here? Jay. 3, 2. It's as easy as that. See how this one has 3, 2? It doesn't have to be right next to each other, but see how they both have the same coordinate? So this solution would be 3, 2. So sometimes it may be as easy as just looking at the tables and finding when they have the same intersection. Right here we can see a graph. What? Because this point technically is 3, 2. Yeah. So that's our solution. And so here, these are already graphed. Sometimes they may say just find the solution. We would know it's where they touch. And that point, who can raise their hand and tell me what is that point of intersection? Someone can tell me. What is it? 33. Because the x is 3 and the y is 3. Yeah, so these are 2 different questions. These are 2 different questions. I just wanted you to see what it looked like on a graph and what it looked like on a table. Now, real quick, I'm going to backtrack because I saw this on your guys' interim. I want to make sure we know the quadrants. And so, remember, if I'm saying counterclockwise, can you draw with your finger what counterclockwise looks like? What is counterclockwise? So counterclockwise is the opposite way of a clock would go, right? And so this one right here is quadrant 1. So counterclockwise, would I be going down or to the left? To the left. So this would be quadrant 2. This would be quadrant 3. And this is quadrant 4. And so we always start with the positive at right side and counterclockwise. So when they're asking you a quadrant, what quadrant would 3, 3 be in? Quadrant 1. And so I saw some people graphing while you guys were doing this question, but I want to make sure you guys do know the quadrants. Make sense? Cool. Let's go to a few more examples. So sometimes it's going to look something like this. And I don't want you to solve it any other way besides plugging in. So what I want you to do, I'm going to talk about calculators. I want us to practice the skill of plugging it in. And I know it sounds silly, and I know sometimes it can be extra work. But I want to make sure you guys understand like how to go about checking your work. You're welcome. And so what I want you to do is I want you to take this right here and plug each point in for x and y and figure out which one works. So like let's look at the first one right here. What is my y coordinate for this first point? 2. And what is your x coordinate for this first point? -5. Those 2 answers, when you do them separately, should equal each other. If they don't, that is not a solution. So let's do this. We'll do the first one together. What is 3 times 2?
6.
Plus 2?
8.
You get 8 on this side. What's 2 times -5? Minus another 5. -15. Does 8 equal -15? No. So I know that is not a solution. So I want you to go through and figure out which one is a solution. When I plug both of them in, which one does one side equal the other side? And so it may seem like a lot of work, but I want to make sure you guys know how to go about plugging in your answers. Because especially on your milestone, your interim, things like that, you can get all the answers, most of them, by plugging in and figure out what works. So sometimes it's not about knowing every single process and doing it right. It's about what's the smartest way to go about it. How many more people need calculators? So you can do it by hand. As soon as you find the answer, circle it, and then I'm going to go back to it. And so you can plug it right into your calculator. So when there's a parenthesis, instead of doing x or y, put parentheses under the number. answer raising your hand? Anyone find the answer? Jalen, what was it? 5, 1. So when I plug in 1 for my y, what is 3 times 1?
3.
Plus 2? 5. Now let's make sure it equals the other side. What is 2 times 5? Minus 5. See how these two sides are equal? I know that that would be my solution. And so you can always do that. Sometimes we're going to be taking a break and just practicing plugging in. Because on your SATs and ACTs and things like that, you're not going to always know every answer. Especially since there's some like calculus questions on there. It's all sort of type of questions. Most of it is Algebra 1. But you could actually figure out most of the answers by plugging it in and figure out which one works. So, who can raise their hand looking at this table, find the solution? Go for it. Beautiful. See how they both have, this is the only point that they share. So that would be my solution. It can also look like this. When they say find where f of x equals g of x, that means find the solution. Okay, so I want you guys to try the next 2 problems on your own. So what you're doing is you're graphing both of them just like we did. See how they're already in slope-intercept form? We can just go ahead and graph them. And then you're finding the point of intersection. Do you guys want me to go over one more with you? Okay, so I'll do one with you. So the y-intercept here at that top one is what is 3, right? So I would always start on my y-axis. Don't ever start on your x-axis. Then, since it's negative, am I going down or up? Down. So I go down 5 from this point, 1, 2, 3, 4, 5, over 3. And I'm always going to the right. Make sure it's rise over run. So it's down 5 over 3. The only time you would go left is if you can't fit it and you have to do the opposite. Like I could go up and left and it would continue the line. And so those are the only 2 points I can fit on this graph. So I'm going to graph that right there. Then I'm going to use a different color. And the y-intercept for this one would be what? -3. And then what would you do? Beautiful. And see how they hit the same point? Some people are giving just the graph to me, but that doesn't mean anything to me. I need to know what is that coordinate, where they meet. 3, that's my x, -2. So that would be your answer. It's okay. This one you're getting a slope-intercept one. So see how we get it right here. Got a lot of that itself. Yeah. So try the next one on your own, and then I'm going to go through the last part of this before I'll give you time to practice. So try the second one on your own, and see if you can come up with a solution. Back here also is the answer key, so as soon as I'm done going over this stuff and you want to stamp, you can always come back there and stamp. Usually they're different colors, so that you know. I'm usually you don't think there's black. Oh, you don't think because this will still stay negative. So this would be slope -1 over 1 and positive 3. The only time it would change, see if that's plus or the minus. That would change. All right, so let's see if we got this one. So your y-intercept for the first one was -1, and you should have gone down 1 over 2. And continue it so that it goes through the graph. You got that first equation right, graphing. Awesome. And the second one, I did that one in blue. I'm going to do in red. I start at my y-intercept, which is -4. And since it's positive, I would go up 1 and always to the right 4. And you should have gotten that point is your solution. What point is that? 4, comma, -3. Beautiful. Who got that? Now, 2 last things I want you to do. I want you to make sure you know how to check your work. And what did we just talk about when we check our work? What did I tell you to use? Plug it in. And so especially when you're on a test, I want you to be able to plug it in and make sure it makes sense. So how do I do that? In your calculator, you're going to write -1/2. And instead of x, what coordinate do we get as x? Right here. For this equation, 4. -1. You're going to do the same thing with the second equation. Instead of x, I'm going to put 4. Both answers should give you the same y. If they don't, then you know your answer is incorrect. So I want you to try that in your calculator. Does everyone know how to put a fraction into a calculator? ND. So if you do negative and then do the ND, 1/2, and make sure it looks like that. If you need help putting it in your calculator, raise your hand, I can help you. But you're putting it so it looks exactly like this, and your answer, when you put it in, should be -3 for both of them. If it's not, then we know it has to work for both of them. If it only works for one and not the other, then we know it's not. Use subtract 8x. Did everyone get -3 when you plugged it in, or does anyone need help putting it into your calculator? No. Anyone else? Was everyone able to get -3 as your y? Okay. I'm going to have you guys turn to the last page, and there's just some special cases that I want to go over with you. So they look something like this. And then I'll have you guys practice. So this one is, these two, the last page is a little bit different, not that page, but this page. And so when I graph this, I'm going to graph these two together. So I have +2, and then my slope is -2. So what do?
You go down 2 and over 1.
Beautiful. And I'm going to keep doing that. Up 2 over 1, and draw a line through it. The next one starts at -2, and I go down 2 over 1. It looks something like this. Who can raise their hand and tell me, what do you notice just looking at the equations that are the same between those two lines? Just the slope. Just looking at like the actual numbers itself. I heard parallel, you guys are ahead of me. Just looking at the slopes.
The one.
What do you notice about them?
They're the same.
They're the same, right? So they have the same slope, but different y-intercepts. So they have the same slope, but different y-intercepts. And I heard parallel. So when you have two lines that have the same slope, but they have to have different y-intercepts, they have different starting points. See how they're never going to touch? It's like when you're if you're driving and like there's two lanes, one's going one way, one's going the other, they're never going to touch. Those are parallel lines. And so how we know they're parallel is it's same slope but different y-intercepts. Those are known as parallel lines. I remember parallel because see the two L's in parallel, see how they look like parallel lines? I can tell they're parallel because when I write the word, I know it should look something like this, where they never touch. So same slope, different y-intercept is always parallel lines. There's no solution. They're never, ever, ever going to touch. So this would be a no solution. Remember when we had like 0 equals 5 when we were solving equations and things like that, and we would say no solution? That's going to come back also. So those actually are the same. When we have no solutions, they're parallel lines. Let's go to this one over here. I'll do this one in red. So I need to get y by itself. I want you guys to try this first on your own. Notice that this one is not in standard form. How would I get, what's the easiest way to get y by itself for the second one? Subtract 3 and put it on that side. So you're moving things around to get y by itself in both of these. See if you can try both of them on your own. I'll give you a few minutes. So sometimes they're not going to be in standard form, like this one is in standard form because x and y on the same side. But that one is not. You're just going to play around with it and move it using your inverse operations to get y by itself. So maybe look at your notes from today. I know, so. Yeah. Mm-hmm. Mm-hmm. So you can do this. You have to bring maybe 3 over 3. So over 3, so you can subtract 3. So you can make it 3. And then divide everything by -3. And that will be. So I'm going to bring it over to 2. Is 3 by it? I'm going to bring it on this side. So right here for the negative. And then all 3 of those should be negative. Now come up with my so we're going to negative. Positive 2, no. All right, so who can walk me through how to do the first one on my board? Who can walk me through on how to do the first one on the board? I think somebody can. You go a little shy. Sure, go.
We would rewrite -2x minus y equals 1.
Mm-hmm.
And then we would put -2x so then we'll cancel.
So what should I do to both sides to get the x on the other side?
Subtract.
It's already subtracted. How would I get out the side? What's the inverse of subtract? Mm-hmm. So I could subtract -2, but it's the same thing as adding 2x. Then what do I do? It's okay. You can fix it. Now tell me what to do. You can fix it. What do I bring down? Negative y equals, and then how do I rewrite that? It's 2x and 1. Can I combine them? No, so how do I rewrite it?
Plus 2x.
Mm-hmm.
Plus 1.
Beautiful. And so since it's plus, it's positive. Perfect. Then, go help me out. What's the invisible number that goes right there? 1. So now what do I do to get y by itself? And what answer do you end up getting? You can do it with me on the board. Get y equals, what's 2 divided by -1? -2. And what's 1 divided by -1? -1. Good luck. they did it, or was on their way to get it. Then this one is a little more difficult. Some people I saw doing it in different ways. So I have negative 6x equals 3y plus 3. And so you want to make sure that when you're doing this, some people like y to be over here, and that's fine. It just takes a little bit more movement. But you could also have just y on this side. It doesn't matter which side it's on. So I'm going to bring the constant 3 over here. Even if you did it a different way, you would still get the same answer. How do I put 3 on this side? Subtract, right? And I can even rewrite this if it's annoying you that way. You can write 3y equals negative 6x minus 3. If you want to change it around like that, you can. Then how do you get y by itself? Divide each one by 3. And when you do that, you end up getting y equals negative 2x minus 1. What do you notice about the two equations that we just did? They're the same slope and the same y-intercept. Same slope, same y-intercept. They are the same line. So just because two lines have the same slope doesn't necessarily mean they're parallel. Because if they have the same y-intercept also, that literally means that they are the same line. They're called coincide. Coincide lines. And what that means, I just basically think like one's inside the other, right? So if I graph this and it looks like this, I know the other one is the exact same line. They're basically inside one another. We call that coincide. So these lines coincide. There's infinite solutions because they are the same line. Every single point is the same, is a solution because they are the same line. So that would be an example of infinite. So when we were learning like 0 equals 0 and 2 equals 0 is no solution, that's literally what we're doing right here. This is just looking at it on the graph. Does that make sense? Okay. So what I'm going to have you guys do is you can start from the beginning if you want and practice in the stamp and the answer keys right there. This is also a different one you can do. So this is an activity where you are graphing each one and you're finding the UFO that it hits, and that's your UFO number. So like if I graph it and the first one, if they both hit 3, I would put a 3 right here. I don't really know what the answer is right now off the top of my head, but that's how you do that activity. So remember, these activities are always open if you guys want to do them at home and get those stamps later on. And so the last thing we're going to do today is your check for understanding, which looks like this. So one's just graphing this one. The other one is moving it around and graphing it and telling you what a solution is. And your homework is literally sitting there, graphing it, finding the solution. Yeah, it's on Delta Math. It's just 5 questions. So remember, they're not due for your unit test. This is the first lesson of unit 4. Your unit test is not for a while. Yeah. We just had that quiz was considered other unit tests. So I'm going to give you time to do that. I'll let you guys know when it's 15 minutes or 10 minutes so that you guys can work on this check for understanding. But start where you guys want to start. So if you feel like you're ready for the check for understanding now, you can do that now. If you guys want to practice a little bit and get those stamps, and every 4 stamps that you get a brain buck. So you can cash it in for candy. Sound good?
Yes, ma'am.
Okay, cool. Okay.